So we're still talking about graphing the sine function and the cosine function, but we're going to direct our attention now to something called amplitude. And as you can read, we're going to begin our investigation to start understanding how each of these constants affects the graph of the sine function and the cosine function. And the first one we're going to talk about is how this constant A. So we're assuming that we don't have a K here, and we don't have a B here, and we don't have a C. We just have some number A, as in the example y equal 2 sine x you see here. So the only thing is the factor, the factor in front of the sine function, or the factor in front of the cosine function. And this changes what's called the amplitude of the function. Okay, so just kind of bear with me for a moment. I know this may be a little more than you want to worry about, but it's important in understanding the bigger picture when we graph things more complicated. So I'm thinking of the 5 important points in the interval from 0 to 2 pi. Remember, y equals sine of x goes from 0 to 2 pi, and then it repeats to the right and it repeats to the left. So bigger x's and smaller x's. And the important, remember, it's breaking that interval from 0 to 2 pi into 4 equal pieces. So we break it in half, we're at pi. We break that part in half, we're at pi over 2. And from pi to 2 pi, if we break that in half, we're at 3 pi over 2. We're going by pi over 2 units. And those are the important parts of the unit circle, aren't they? From 0, then vertical, pi over 2, then horizontal, pi, then vertically down 3 pi over 2, and back to the original 2 pi. Okay, so those are the 4 important pieces of the unit circle, and then this gives us our complete revolution. Okay, well, when we graph y equals sine of x, then the value of sine of x is the y value. So here are the x values, and there are the y values. And so on those 4 important pieces, the y values are 0, 1, 0, -1, and 0. And of course, when x is 0, sine of x is 0. So y is 0. When x is pi over 2, sine of pi over 2 is 1, and so y is 1. So this represents the y value when we're graphing y equals sine x. Now, we want to graph y equal 2 sine x. And so our y value is going to be 2 sine of x using these x values. But that's very simple when we just look at this row above. Since this is what the sine of x is, then if we just multiply that by 2, this is 2 times the sine of x, or y. So multiply this by 2, we get 0. Multiply this by 2, we get 2, and so on. So these are the new y values for these important x values. Well, let's look at the graph. Now, what you see right here, this little dashed black line, wave, okay, called the sine wave or the sine curve, this is y equal the sine of x. And what we've done, though, is we want to graph y equal 2 sine x. I guess I should have put it in blue, but I put it in red. So at the important value of x equals 0, we still have a y value 0. That's this point. 0, 0 is still on here. But the important x value of pi over 2, which would have been at the top of the amplitude, we say, okay, at the top of the amplitude, in this case, then, we're twice as much as that. We're y equal 2 for our new graph. So instead of being here a y equal 1, we're at y equal 2. So simply stretch that out, which we've seen before. Now, when we get to the next important x value, which is pi, then our y value is still 0. And so we come back to this point. And then our next important value of x, 3 pi over 2, then our y value is -2. So instead of being at -1, it's all the way down here. But you see, it's mimicking, it's just going higher and lower. And then when we get back to 2 pi, then our x value our y value once again is 0. So we're back to this position. So this graph looks similar, except it's stretched out vertically, isn't it? It goes twice as high, it goes twice as low. And by the way, this distance from the x-axis here to this top of the hump or top of the amplitude, that distance is called the amplitude. So in the regular y equals sine of x, the amplitude is 1. And see, the distance from here to here is also 1. It just goes down to -1. So this distance is 1. The amplitude is as far away as the graph gets from the center, if you will. In this case, it goes as high as 2, so this distance being 2, that is the amplitude. 2 is the amplitude of this graph. And also it goes 2 units away, except in the negative direction, but the amplitude is 2. And of course, this graph continues both to the left and right. And that's what's meant by those dashed lines. Okay, so bear with me as I read to you some. As it says here, we're talking about amplitude. We'll normally sketch the graph over the home interval, okay, which contains one complete cycle. And right now our home interval is 2 pi units long. After that portion is completed, we'll extend the graph using the fact that that cycle is repeated over and over. So we can extend to the right and extend to the left. Now, in the example we saw, this a that was in front of sine x in the example we saw, it was a 2. This constant factor a that is in front of the sine function or a cosine function acts as a vertical scaling factor, as I'm reading to you here. A vertical stretch or a vertical shrink if that a value is smaller than 1. So if the absolute value of a is greater than 1, the basic sine curve or cosine curve will be stretched. If the absolute value of a is less than 1, then the basic sine curve or cosine curve is shrunk or compressed toward the x-axis. The result in this case, then, the result is that the graph of y equal a of sine of x ranges between a low of -a and a high of +a, instead of a low of -1 and a high of +1 with the regular sine function or cosine function. So here is the definition of the amplitude of sine and cosine function. The amplitude of the sine or cosine function, the amplitude of y equal a sine x or y equal a cosine x, represents half the distance between the minimum and maximum values of the function, which, as we saw a while ago, I just said from the middle, from the x-axis, but really we had a low of -2 and a high of +2, and it's half of that distance. And the way we actually can determine that is just look at whatever the absolute value of this number is. So when we had y equals sine of x, it's understood that the a value is 1, the amplitude is 1. When we had y equal 2 sine of x, then of course the absolute value of 2, which is just 2, the amplitude is 2. That tells you how high or low the graph is going to go. Now, back to, okay, consider again, vertical shrinking and stretching. In the case of y equal 1/2 of cosine x, this is the a value, so the amplitude is the absolute value of that 1/2, which is 1/2, which means the maximum height will be 1/2, the minimum height will be -1/2. But the amplitude is 1/2. Y equal 3 cosine x, the amplitude is absolute value of that 3, which is just 3, so that's going to have a maximum height of 3 and a minimum height or value of -3, but the amplitude is 3. Okay, I'm going to graph both y equal 1/2 cosine x and y equal to 2 above, y equal 1/2 cosine x and y equal 3 cosine x. So these represent y values. What did I do? I took the original interval, the home interval from 0 to 2 pi, because we know one cycle or one period happens there, and broke that into the 5 important pieces into quarters: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now in the original cosine function, when y equals cosine of x, then our y value is 1 when x is 0, and our y value is 0 when x is pi over 2, because cosine of pi over 2 is 0. And our y value is -1 when x is pi, and our y value is 0 when x is 3 pi over 2, and so on. You know, we're back, because the cosine of 3 pi over 2 is 0, that means our y is 0. Well, in the graph of y equal 1/2 cosine x, we're not changing these important x values. What's changing is how this 1/2 affects our y values. And so our new y values are going to be 1/2 of cosine x, or 1/2 of these values. So our new y value is 1/2 of 1, which is 1/2. 1/2 of 0 is still 0. 1/2 of -1 is still -1/2. 1/2 of 0 is still 0, and 1/2 of 1 is 1/2. And likewise for y equal 3 cosine x, our new y values are 3 times the cosine x, and the x's are up here. So we get a 3, a 0, -3, a 0, and a 3. Now what I've done is I've graphed all three of these graphs on the same coordinate axis. The little black graph here is y equal cosine x, and remember it starts up here high because the cosine of 0 is 1, so x is 0 and y is 1. And then the first quarter point puts it here, first quarter of the way. See, here's all the way through the period, 2 pi. So the first quarter of the way, it's where pi over 2 is, and the cosine of pi over 2 is 0, so our y is 0. And then when we get to pi, that's halfway through the basic interval, okay? Well, the cosine of pi is -1, so our y is -1. X is pi, our y is -1. And then we get to 3 pi over 2, and it's back to an x-intercept because the cosine of 3 pi over 2 is 0. And so our y is 0. And then when we get to 2 pi, our cosine of 2 pi is back to 1. And so we've made a complete cycle. After this, it starts again. So this is y equal cosine of x graph. Well, what's going to happen with 1/2, y equal 1/2 cosine of x, is just shoving all those high points or low points by a factor of 1/2. Instead of being up at 1, it's at 1/2. But it still goes through here. Instead of being down at -1, it's at -1/2. But it still goes through this x-intercept, and then it goes back to 1/2. And so it shrinks that, if you will. This distance is 1/2. The distance from the high to the low is from -1/2 to +1/2 is 1, and the amplitude is half of that. But it's this distance we think of as the amplitude, okay? This distance as the amplitude. And when y is equal to 3 cosine x, well, now the amplitude is going to be 3. So it's going to, instead of start here at 1, it's going to start up here at 3, still go through this point, go as low as -3, still go through this point, go as high as +3 again. And so this is one complete cycle, and it's going to repeat that cycle over and over to the left and to the right. So hopefully we understand that idea. Now, let's look, we need to be a little careful because sometimes that factor in front of the cosine function or the sine function can be a negative number. And that's the reason we worried about this amplitude being an absolute value. Okay, so here we're looking at y equal -3 cosine x. It's still this factor that determines the amplitude, and the amplitude is the absolute value of that number, -3, which is 3. Okay, so it's still the maximum value is going to be 3, and the minimum value is going to be -3, but this negative causes a reflection in the x-axis we'll see in a moment. So I'm still looking at the same important x values. And when I had y is equal to 3 cosine x, the important y values were 3, 0, -3, 0, and 3. But now I'm looking at y equal -3 cosine x. And so instead of at x equals 0, instead of having cosine x a value of 1, I multiply that cosine x value by a -3. So I get a -3. -3 times 1. -3 times 0 is still 0. -3 times -1 is +3. -3 times 0 is 0. -3 times 1 is -3. All we're doing is multiplying cosine x right here by a -3 to get these y values. And remember, these represent y values, and these are my x values. So here's the deal. When x is 0, in my graph on the previous page, my y value was 3. See, that was way up here. But because I'm multiplying by a -3, my y value is -3. So that -3 caused me to start low instead of high. So I started low, but I still go through this point, and then I get to a high point, and then I get to an intercept again, and then I get back to a low point. So from here to here is one cycle, and it repeats that over and over. So again, we just need to know what's happening at these landmarks, either high or low. See, high, intercept, low, intercept, high, intercept. Well, because of that negative, instead of being high, we start low, but it's still intercept, and then it'll go to high, and still intercept, and then it'll go to low, and then back to intercept. So knowing those pieces allows us to do these graphs pretty easily. Oops, sorry about that. That just took me right back to the very beginning. So that's all I want to say about amplitude right now. We'll look at some specific graphing examples a little later, but hopefully this will take care of getting you started.